Hello and welcome back, guys. Welcome back. I'm sure you have enjoyed some of the previous videos on trigonometry from the grade 10 work and all that. So now let's go on to identities. So in grade 11, we just have two identities that we use back and forth, and also we try to use it in different forms, but we just have two identities, right? So we are going to deal with those identities, right? So from previous work, we have learned that sine of theta is equals to y over r. Our cos of theta is equals to x over r. And lastly, our tan of theta is equals to y over x, right? So if we take a look at this, if we get sine of theta over cos of theta, this is the same as sine of theta divided by cos of theta, right? And our sine of theta, know that this is y over r divided by x over r. But mathematically, this is the same as y over r multiplied by r over x. And r can cancel out, and we can be left with y over x. And which y over x, it is the same as this. So it means that this is the same as tan of theta, right? So this is our first identity. We know that our sine of theta over our cos of theta should be equals to tan of theta. So it means that whenever we are having the angles that are the same here, they always give us tan of that very same angle. So it is the same as if we're having sine of 10 over cos of 10. This is the same as the tan of 10, right? But we can also deal with the reciprocal of this, right? So it means that if we change this, so this is the same as like this, right? So if we change this, this becomes cos theta over sin theta, which is the same as 1 over tan of theta. Can you see that? So this is one and the same ratio that we just swapped in, right? So no matter what you're doing, most of the times when you're doing proving the identities or simplifying the ratios, always remember to always change tan theta into sin theta over cos theta. Wherever you see tan theta, try to change it as fast as you can, right? Okay, so this is our first identity. So let's go on to our second identity, right? So we have also learned that by the theorem of Pythagoras, that our r squared is equal to our x squared over plus our y squared, right? So it will also mean that if we divide throughout by r squared, and r squared, it means that our situation now is going to give us 1 this side being equals to x over r squared plus y over r squared, right? But again, we've explained already that x over r is the same as cos of theta, right? So this will be cos theta squared plus, and this is sine, so this is sine theta squared. So it means that whenever we are having one or whenever we're having this situation, we can use either how in terms of how we want to or what we want to achieve, right? So it means that always cos squared theta plus sin squared theta is equals to 1, right? And also algebraically we can change it in any way. So also 1 minus cos squared theta is equals to sin squared theta, right? And also 1 minus sin squared theta is equals to cos squared theta. So all these can be used and they all follow under one ratio, which says that cos squared theta plus sin squared theta is equals to 1. So these are the identities that we have so far, and the identities that we are going to deal with in this grade, right? So I hope you have learned that. So now I'll just show you how you can use these identities, right? So we use these identities to try to achieve whatsoever we want to achieve, right? It's either to expand or to compress any situation that we are having, right? Okay, so let's take a look at this example that is saying sine x over cos x multiplied by the tan of x, right? So I said every time you're having tan of x, always change tan of x into sine of x over cos of x, right? So this situation of ours becomes sine x over cos x multiplied by sine x over cos x, right? So it means that now cos x and cos x can cancel out, and we'll be left with sine x over sine of x, which these two can also cancel out, and our answer here is 1. As simple as that. So let's get to the second example. Okay, so taking a look at this second example, can you recognize this? We said 1 minus cos squared x is equals to sine squared x. So this will change to sine squared x. So we're going to have sine squared x over sine x, right? And sine squared x over sine x, this becomes one of the signs here will cancel this, and we're going to left with sine x, like that, right? Can you see that? So let's take a look at a third example. Okay, now we're having this one, and already we've said if we're having tan theta, we can change that into sine and cos, right? But now this is having a squared, so it means that each will get a squared, like that. So it means that this becomes sine squared x over cos squared x. And now this, we can change this into what? Into cos squared x, because this is our identity. We took this from sine squared theta plus cos squared theta is equals to 1. So it means that if we are taking sine that side, it becomes 1 minus sine squared x, which will just give us this. So this will be multiplied by cos squared x, and cos squared x and cos squared x can cancel out, and we are going to left with sine squared x as our answer. So that's how we can solve this, right? So guys, just like always, I'm also going to leave you with checkpoint 11, and then from checkpoint 11 I'm going to show you how to prove the identities now. So now we're just doing this with the ratios only, like with the identities only. We haven't included the reduction angles yet. So the reduction angles, I'll do it on the next video, but for now let me show you how you can prove the identities, right? And do the checkpoint 11 before attempting proving the identities. So now, after learning how to use the identities, proving the identities becomes easy now. So what do you do when you are proving the identities? So when you are proving the identities, mostly you want to prove that your left hand side and your right hand side, they're equal, right? So you're trying to prove that your left hand side and your right hand side are equal. So your first take is to choose one side. So you choose one side. So you choose one side to prove, right? So from then, choosing one side to prove, what's your next take? Now you have to choose the complicated side. You have to choose the complicated side, or you have to choose the side with more information, right? And then from then, after taking the complicated side, now we have to check the side that we haven't chosen, right? Now we have to check the other side. Now you have to check the other side. So just like if your other side is saying maybe you have to prove that your left hand side is equal to tan theta. It means that on your left hand side you must prove that that identity is equal to sine theta over cos theta, so that it can give you this solution, right? So it means that whatever that you are having to prove, it means that you must try to see what is on that other side you are trying to prove, so that you can simplify it, or you can try to go to that direction, right? So let me show you an example of that, and then you can see how you can do this, right? Okay, so this is what we are trying to prove. So obviously the complicated side, it is this side, right? So we are going to take that complicated side. So already we can see that we are trying to prove that this is equals to tan squared x, and already we know that tan squared x must be given by sin squared x over cos squared x. So we'll try to prove this side to be left with sin squared x over cos squared x, and they'll be equals to that. So let's go on. So we've chosen up the left hand side. So we have chosen the left hand side. So this will be equals to, in this left hand side, you can see that here we can factor out the cos, right? So after factoring out cos x, this becomes 1 minus cos squared x all over, and here again we can factor out the cos x, and this becomes 1 minus sin squared x. So this and this can cancel out, right? And 1 minus cos squared x, we said is equals to sin squared x, and 1 minus sin squared x is equals to cos squared x. So sin squared x over cos squared x, this is equals to tan squared x, and this is equals to the right hand side. As simple as that. Can you see that? Let's take a look at another example, guys. Now we are asked to prove that tan squared x multiplied by cos squared x plus sin squared x over tan squared x should be equals to 1, right? So already if you are asked to prove that something is equals to 1, it's either everything here must cancel out, or everything else there must be sin squared x plus cos squared x. So if you can have a situation like this on that side, then it means that it is equals to 1. So let's try to prove that. And again, this is our complicated side, right? So let's see. So we've picked up our left hand side. So with our left hand side now, what is tan squared x? I told you that every time we're having that, try to change it into what? Into sine and cos, right? So this becomes sine squared x over cos squared x multiplied by cos squared x, right? Plus, and then this is the same as sine squared x divided by, and this is sine squared x over cos squared x. Can you see that? And now this and this can cancel out now. Can you see? And you're going to be with sine squared x plus sine squared x multiplied by, because this is a division, and if you're dividing by a fraction, you can multiply and reciprocate the fraction. So this will be cos squared x over sine squared x. So this sign and this sign will cancel out, and we'll be left with sine squared x plus cos squared x. So sine squared x plus cos squared x, this gives us 1, and which is equal to the right hand side, just like that. Can you see that it is simple, guys? You just follow through whatever that we did, and you can see that working with this is very, very simple, guys. It's very, very simple. So it means that, having said that, I will leave you with checkpoint 12. So it means that so far the checkpoint 11 and the checkpoint 12 is just a matter of identities, right? So our next lesson will be on reduction formulas. We'll be dealing with reduction formulas. So guys, like always, if you haven't subscribed, please subscribe and share this video with your mates, and also like this video, and you can put in the comments if you feel like we are doing the great work, or if you feel like we are not doing enough. You can also like advise us on what to do, so that we'll keep creating the great content that will help you guys. So see you on the next one.